can you solve this geometry challenge? Here's the question. Given a square with an area of 1 square unit and another square having an area of 4 square units. Now let's draw a circle such that this circle is tangent to the floor and tangent to the tip of our squares. And the question is, what is the area of this pink? Pause this video right now and see if you can answer this question, because I will show you the solution in 3, 2, 1. Alright, so to find the area of this pink, what we're going to do is to focus on the center of this. Now, from the center of our circle, let's draw a radius directly to the point of tangency, and we know this creates a 90 degree. Now, consider this point, the tip of the square having an area of 1 square units, and let's connect this to the center of our circle, and let's call this as R. Now, from this point, let's drop a perpendicular segment like this, and take note, this measures equal to 1 unit. And since the whole thing is our radius, so this length is just R minus 1. And now from here, let's call the length of this segment be equal to x. And now we created a right triangle having side of R, R minus 1, and x. So we can use what we call the Pythagorean theorem. And using Pythagorean theorem, we have an equation x squared plus R minus 1 squared equals R squared. Now, we have two equations. So, in short, we need another equation in terms of x and r and solve for the value of r eventually. Now, if we get the value of r, we get the area of this pink circle. Now, the next question is, how do we get the second equation containing x and r? So, we will use what we call the second intersection point. So, the tip of the second square having an area of 4 square units like this. Now, since this is 4, so this side simply equal to 2, and the length of this segment is just r minus 2, or the radius minus these 2 units. This is r, and this is x plus 1, because right over here, this is just x, and this is 1 unit, so this is just x plus 1. So again, using Pythagorean theorem, we can say that x plus 1 squared plus r minus 2 squared equals r squared. Now we have two equations in terms of x and r. So in short, we can now solve for the value of r. But take note, in our diagram, the length of the radius must be greater than 2. Now let's focus on these two equations and solve for the value of r. And let's focus on the first equation. Now what we're going to do is to subtract r minus 1 raised to the power of 2 of both sides. Now take the square root on both sides. So x equals square root of r squared minus r minus 1 raised to the power of 2. Now let's set aside this result. And let's get this second equation. We will do the same thing. Subtract r minus 2 raised to the power of 2 on both sides. Take the square root on both sides. And let's set aside this result. Take note that this x is equivalent to this square root of r squared minus r minus 1 raised to the power of 2. So we can replace this x with this equivalent in terms of r, because the goal in this question is to solve for the value of r. Now we can now solve for the value of r. So what we're going to do is to simplify this a little bit. Next, simplify the expression inside our radical sign. So this becomes square root of 2r minus 1 plus 1 equals square root of 4r minus 4. Now let's focus on this result, and to eliminate the square root, let's square on both sides. So the left hand side is just 2r minus 1 plus 2 times the quantity 2r minus 1 plus 1 equals 4r minus 4. Now combine like terms, this will give us 2 times the square root of 2r minus 1 equals 2r minus 4. Divide all of this term by 2, we have this equation, and let's focus on this result. Now to solve for the value of r, let's square on both sides. So the right hand side becomes r squared minus 4r plus 4. Now combining like terms, or equate this to 0, this becomes 0 equals r squared minus 6r plus 5. And we can factor this out nicely as r minus 5 multiplied by r minus 1. Now using the 0 property, at least one of them one of these factors equals to 0, sub r minus 5 equals to 0, or simply r equals 5, and r minus 1 equals 0, or we get that r equals 1. Now, since r is greater than 2, so we can now reject r equals 1. Therefore, r here simply equal to 5 units. So, going back to our figure, we can say that the radius of this circle simply equal to 5 units. And we can now find the area of the circle. This is by using the formula for the area of the circle as pi r squared. Now, r is 5, therefore the area of this pink circle simply equal to 25 pi square units. And that is our answer to this question. And of course, before we end this video, let's have an extra challenge. So this is the extra challenge. Same scenario, but the area of the small square is 4 square units and the area of the big square is 16 square units. The question again is find the area of the pink circle. And as always, we are done.